Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have discussed about the effective atomic number, that is EAN, and also we have discussed about how to calculate it. And now in this topic let me talk about the rules regarding the IUPAC nomenclature for the coordination compounds. So what are those? Let me talk about that in this topic. So friends, in this topic let me introduce you the most important points regarding the rules for the IUPAC nomenclature of the coordination compounds. So starting with the first one, we have the name of the cation is named first, followed by the name of the anion. This is the most important part, that is what I'm going to talk about. So let me clear this point with the help of an example, and the example is, so here are the two complex for which we have to give the nomenclature, but before that we have to understand that is how the nomenclature rules goes on. So as we have discussed, that is we have to give the name of the cation first, and then after we can give the name of the anion. So if we talk about this complex, that is K3, where Fe is the central metal atom which is surrounded by, that is 6 moles of the cyanide ligand. So in this case basically the potassium is the one which is acting like a cation. So therefore the name of this complex, it will start with potassium, and then it would be followed by the, that is anion, that is in this case it is the ligand, that is cyanide. So what is the name of this complex? This is what we are going to talk about in the end of this session, but let us follow the certain rules. So according to the first rule, what we have did is we have given the name of the cation first, followed by the name of the anion. So now in this complex, basically here the cation is cobalt. So that's the reason we have to give the name of cobalt first, and then it will be followed by the negative ligand or the negative ion. In this case it is chlorine. So therefore the name, it will start with cobalt. But there are also certain rules regarding the ligands, so even we have to follow that. So this was nothing but it was a small example related to the first rule, and now let me talk about the second rule. The second rule is a complex cation is named by naming the ligand and then the metal ion, while the oxidation state of the metal ion is written next to the metal ion in Roman number with the parenthesis. So this is the rule, that is what I'm going to explain with the help of an example. So now let me give you a particular example so that we could understand this rule. Friends, this is the example which we have to give the IUPAC nomenclature, but before that we have to understand the second rule. So in this case this complex is what we have, and this is nothing but a cation complex, and here basically we can see that is it has a charge of 2+, which makes this complex to be known as a cation complex. But here the name, it should start with a particular cation. But in this case the copper is a cation, while the NH3, they are the neutral ligands. But as we have discussed earlier also, that is we have to give the name of the ligand first and then the metal, provided we should also know the oxidation number of the metal. That metal. So in this case basically we can find that is there are 4 amines group that are attached to the copper, and that's the reason we could name this as, since here basically there is 4 moles of amines that are been attached to the copper, so therefore we could also name it as tetra amine, and this is nothing but the copper. So we'll write it over here as copper. But for that we should also know that is what is the oxidation number of this copper or this central metal atom. So in that case we'll get to know that is this NH3 is a neutral ligand, and that's the reason that is the oxidation number of this copper, it will be found to be 2, but we can't write it +2. So for that we have to represent it with a Roman number 2 with parenthesis. So this is how basically we have to provide the name, but this is not the complete name. I am just following the rules, and at the end of this lecture I am going to provide certain complexes for which we have to provide the IUPAC nomenclature. So therefore these are the certain rules that I am going through, and now let me discuss about the next one. So talking about the next rule, we have that is a complex anion is named by writing the ligand followed by the name of the metal, but ending with the suffix ate. So here also we are following the same second rule, but here there is a bit difference. The thing is, here we are considering a complex anion, but in the previous one we have considered complex cation. And the small difference is that is the name, it will end with ate. So now let me give you an example related to this so that we could understand this rule perfectly. So for that we have a complex that is FeCN6 4 minus. So this is the complex that we have, and here basically we can see that is the complex has a charge of 4 minus, which makes this complex to be called as complex anion. But for the naming, as we have already discussed here, that is we have to provide the name of the ligand first, followed by the name of the metal ion. So in that case we could get to know that is the cyanide is acting like a ligand, and then here basically the metal ion is nothing but Fe. Suppose if we have to calculate the oxidation number of this Fe, then we could calculate it, because in the previous lecture only we have discussed about the EAN, that is effective atomic number. So in that case we'll get to know during the calculation that is the Fe has an oxidation state of +2. But we could also give the name of Fe as ferrous, because Fe has an oxidation state of +2. But the complex has a negative charge on it, so that's the reason the name it will end with ferrate, followed by the oxidation number of the central metal ion, that is 2. So therefore I could name, I'm talking about the end part, it will end with ferrate with ATE being mentioned over here. Then I could write the Roman number 2. So here I am not writing the previous one because we have a separate session for that, so as to give the nomenclature to the complexes. So this is the third rule, that is what I have discussed about. And now let me talk about the next one. So the next rule is a non-ionic complex is named in one word. So let me give you an example so that we could understand this one. Suppose if we have this complex. Here basically we can find that is there is no charge on this complex, neither positive neither negative. Basically this is nothing but a neutral ligand that has been associated with this nickel. But this is also called to be non-ionic complex. The reason behind that is because in this complex we can't find any charge of positive or negative. But how we can name this? The name of this is being followed by the first rule, second rule, that is what we have discussed. So therefore here basically we can find that is there are 4 moles of carbonyl group or carbon monoxide that are been surrounding the nickel, and that's the reason the name of this one could be given as tetra carbonyl nickel. But since here there is no oxidation state because the overall complex is nothing but a non-ionic complex, so I would write it over here as 0. And this is how basically we could give the name to a non-ionic complex. So next is the fifth rule is when there are 2 or more different ligands present, they are named by the alphabetical order. So here also we have to give a particular attention to this one, because as we understand that is the metal ion can be surrounded by the similar or different kind of ligands, and that's the reason that to provide a name according to the IUPAC nomenclature, it is very much essential for us to understand the rules of it. And the best rule is we have to remember all the time is we have to follow the alphabetical order. So now based on this, let me give you a particular example. So this is the complex that is what we have, and here we can see that is the platinum is acting like a central metal ion, while here NH3 and Cl2, the both are acting like a ligand. But there are different kind of ligand, that is 2 different kind of ligands, that is one is ammonia, that is NH3, and the other one is chlorine. But here we could find that is the amine, it starts with A according to the alphabetical order, while Cl it starts with C. So in that case we have to give the name of the amine first, and then it will be followed by the chlorine, and then we could give the name of the metal, which is the center metal atom, and then it would be followed by the oxidation number. So based on this all things, that is what we have discussed, the name of this one could be given as tetraamine dichloro, then it is platinum. But if we find the oxidation number of this platinum, we would find it to be 4. So therefore I will write it in Roman number 4 in parenthesis. So therefore this is nothing but the name of this complex, but this complex is nothing but an ion, as you can see over here. So therefore it will not end with here, it will end with. So this was nothing but the fifth rule, but there are also many rules. That is what we have to consider. And what are those? Let me talk about that also. As we discussed about the different types of ligands, even here we are going to talk about the different types of ligands and how to name it. So here basically there are a list of certain ligands. For example, if bromide is attached in the form of a ligand, then the name of the ligand, it will be bromo. For chloride it will be chloro, and for hydroxide it will be hydroxo, for cyanide it will be cyano, for oxide it will be oxo, and for carbonate it will be carbonato. So in all this case you could find that is, and those which are neutral, they have a specific name. For example, if you talk about ammonia, so ammonia is the one which we have to give the name as amine. For carbon monoxide, we have to give the name as carbonyl. For water, we have to give the name as aquo or aqua, and ethylene diamine. So this are the neutral ligands, and even ethylene diamine tetraacetate. So this all are the neutral ligands, and here basically we have got to know that is the negative ligands, or basically the anion ligands, they end with the name O. So this is also the rule, that is what we have to follow, and according to the alphabetical order also. So now let us follow the next rule, which is, so the next rule is, that is when two or more identical ligands are present, they are named using the prefix di, tri, tetra, etc. So this is the common thing, that is what we know, but still let me give you an example related to this one. Suppose if we have a complex ion, that is Cu, NH3, 4, and this is 2 plus. So here basically we can find that is the NH3, that is the ammonia. Here we can find that is 4 moles or 4 ammonia molecules are surrounding this copper ion. So therefore the name of this one could be given as tetra amine. This one is copper, but having an oxidation number of 2 plus, because NH3 is nothing but a neutral ligand. So here basically the oxidation number, I will write it over here in parenthesis, and since it is an ion, so I will write it here as ion. So this is how basically we have to give the name, and it is one of the most easy concept to understand how to give the nomenclature to the coordination compound. So this was the 6th one, and now let me talk about the further points. The next point is, the chelate ligands have complex names having the prefix in the name itself. The number of such ligands are given by the prefix bis, tris, tetrakis, etc. So in this case, let me give you an example so that we could understand this rule. So friends, this is the complex, that is what we have, and here we have a particular ligand which is nothing but a chelate ligand, that is ethylene diamine. So how we can name this complex? It is very much simple. For example, here we have to decide which are the anions that could be dissociated. So here basically we could find that is the chlorine is the one that can dissociate very easily, and that's the reason this overall complex will give us a cationic complex and after dissociation. So here basically the chlorine, since it has a minus charge, while the overall complex it will have a charge of plus. So here basically we have to provide the name to this one. So according to the alphabetical order, so we have to consider. So cobalt is nothing but it is the metal which we have to give in the form of a suffix. We have to give the name, but before that we have to also consider the ligands. So here there are two different kind of ligands, that is one is ethylene diamine and the one is chloro. Here we can find that is the chloro is the one which has an alphabetical order, that is it starts with C, while ethylene diamine it starts with E. So in that case we have to provide the name of the chloro first, and so since in this case basically 2 chloro are attached to this cobalt, so therefore we could name this as dichloro. After that we could find that is there is another ligand, that is ethylene diamine, but ethylene diamine has already the suffix di in it. So that's the reason that we have to give the name as bis. It means 2. Bis ethylene diamine, and then I could give the name to the central metal atom in this case, or the ion in this case it is cobalt. So I will write it over here as cobalt. So for that we have to also find out the oxidation number of this cobalt. But here we can see that is the chlorine is present in the outer sphere. So therefore we could name this as chloride. But suppose if we have to calculate the oxidation number of this cobalt, then it is very much simple to understand. That is, suppose if the overall complex has a +1 charge and each Cl has a charge of -1. So in that case, according to the calculation, that is what we have did in the previous lecture during the determination of EAN. So here we'll get to know that is the cobalt has a oxidation number of 3. So I am writing it over here as, so this is nothing but the name of the complex, that is dichloro bis ethylene diamine cobalt 3 chloride. So this is one of the example which I have mentioned over here, and now let me talk about the further examples. So friends, this is the another example for which we have to provide the IUPAC nomenclature. So here we can see that is whenever this complex, if it gets dissociated, then we could get the cationic complex, that is this one. Since Cl is the one that will be dissociated and each Cl has a charge of -1, so there are 3 Cl attached over here. So therefore the overall charge on this complex, it will be +3. So how to give the name to this one? So as we have discussed earlier, that is we have to provide the name of the cation first. So in this case, this is the cationic complex, that is what we have. So in that case, the chromium, it will be appearing first before the chloride. So therefore let's give the name to this one. Here we can find that is the ligand is nothing but a chelate ligand, that is ethylene diamine. But there are 3 ethylene diamine that are surrounding this chromium ion. So therefore we could give the name to this one as tris ethylene diamine, and then here it is chromium. Since here we can find that is the oxidation number of this chromium, it will be found to be that is +3. So therefore I am writing it in parenthesis, also in Roman number. And after that we could also find that is the chloride molecules are also present in the outer sphere. But we will not write the number of chloride, we will only write chloride. And that's it. So this is how basically we can give the nomenclature to such complexes. And so this is the another complex, that is what we have, and we have to provide the IUPAC nomenclature. But we also understand that is whenever this complex, it will get dissociated, it will form a cationic complex and the anion. But this anion, it will get dissociated in the solution, while this will be as it is. So here basically we have to provide the name, but here the ligands are of 2 types, that is one is amine and the one is chloro. But the amine, it starts first according to the alphabetical order. So therefore we could name this one as tetraamine dichloro, and after that we have to provide the name of the metal ion. In this case it is cobalt, so we'll write it over here as cobalt, and we have to find out the oxidation number. So in that case we'll get to know that is the oxidation number of this cobalt, it would be found to be 3. So here I'm writing it in parenthesis, and after that we could find that is a chloride ion in the outer sphere. So therefore I will write it over here as chloride. So this is nothing but the name of this complex. And now let me talk about the last one. So this is the complex, that is what we have, and we have to provide the IUPAC nomenclature. But this is an anionic complex, because whenever this complex, it will get dissociate, it will dissociate into that is 3 moles of potassium, that is K+ ion, and this will be the anionic complex, that is what we could get. So here basically we have to provide the name of the cation first, and in that case it is potassium. But here the potassium are 3 in number, but we have to give only one number, that is, but here the potassium are 3 in number, but we have to give only one name, that is potassium only. So therefore we'll name it as potassium, and then we'll come back to this complex anion, where we could find that is there are 6 cyanide ligands attached to the Fe ion. So therefore we could name it as hexacyano. Remember, we have to give the cyanide the name as cyano. So therefore the name is hexacyano, then this is Fe. But here we have to also calculate the oxidation number of Fe here. So here basically we'll get, that is, since the potassium has +1 charge on it and there are 3 potassium that are on the outer sphere, so therefore there will be 3 positive charge, while on the complex there will be 3 negative charge. So in that case, by calculating, we could get to know that is the Fe has a charge of 3 plus oxidation state, but here the complex has minus charge on it, so therefore the name, it will be ferrate, having an oxidation number of, and that's it. So therefore the name of this is potassium hexacyanoferrate 3, and this is how basically we give the IUPAC nomenclature to the complex compounds, and that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.